Section 2, compound interest. All right, so simple interest applies to loans that are generally less than a year. Okay, so for longer periods of time, compound interest is used. Okay? It's the same sort of concept, except that with compound interest, interest is paid not only on the principal, but also on the interest earned along the way. So you actually get interest on your interest. It's compounded. Okay, so our first example, suppose that $1,000 is deposited at 5% interest for several years. So we're going to track what happens. So this is over the course of 3 years. So at the end of 1 year, $1,000 earns 5%, which turns out to be $50. So 1,000 times 0.05 is $50. There's our interest. Well, so what happens is that interest is now added to our principal. So our principal is now $1,050. So now $1,050 times 0.05 gives us $52.50, $52.50. Okay, well now when you add that interest in, as you can see, the amount of interest is actually going up. As we add that to our principal, we get $1102.50. Okay, 1102.5. Now, in the next year, after that, into that year, $1,102.50 times 0.05 gains $52.125, so 13 cents in interest. All right, so if we added this interest up over the course of these 3 years, okay, add those up, you get $157.63 rounding it. All right, now we're going to compare this to the simple interest accrued on the same amount at 5% for 3 years. So I equals PRT, so $1,000. $1,000 times 0.05 times 3 for 3 years. That comes out to be $150. Now that is not substantially larger, but we've only gone for a period of 3 years. As this continues to increase, $55 turns into $60, which turns into $70, which turns into, and it builds very fast. And in fact, the equation for this, on this next page, is compound amount, A equals P times 1 plus I to the N, where I is the rate divided by the compounding periods, okay, and N equals the compounding periods times the time. So R is the interest rate, M is the number of compounding periods per year. Now this turns out to be, if it's yearly, if it's annually, okay, then M equals 1. It's compounded 1 time that year. Semi-annually, okay, that means M is 2. It happens twice a year. Let's see, quarterly. Quarterly, M equals 4. It happens 4 times a year. Let's see, next you could have monthly. In that case, M happens 12 times a year, so M is 12. And you could actually get up to daily. For daily, we generally either will assume that M is 360 or 365. The point is, compounding periods is how many times it's compounded per year. And then I is interest rate per period. So we actually divide that interest rate by how many times it's compounded a year. All right, so example 2, suppose $1,000 is deposited for 6 years. I'm going to go ahead and underline this. That is our principal. That's the deposited amount for 6 years in an account paying 4.25% per year, compounded annually. Annually says that M equals 1. All right, so to find the compound amount, okay, we are going to take this formula. We're going to have A equals P times 1 plus R over M, so that's 0.0425 divided by 1, since M is 1, to the M times T. So $1,000 plus this amount right here to the 6. Right, now, I've actually worked all these out in advance, so one big point I need to make is that as you go through these videos, any of the videos I make, you need to make sure and pause and work these things out on your own, because you gotta make sure you can do it in the calculator, or you can do it on your own, right? So the answer, when this actually turns out to be $1,283.68. Okay, and that is dollars. That is the future value. Okay. Now the amount of interest earned, interest is going to be this amount right here, okay, plus or minus the initial amount. So this minus 83.68 minus the original amount, which was $1,000. So our interest is $283.68. Okay. Next, example 3. Find the amount of interest earned by a deposit of $2,450 for 6.5 years at 5.25% compounded annually, or compounded quarterly. Okay, so quarterly means M equals 4. There's our rate, deposit, so that's P, and we have time. All right, so we will go back into this formula, A equals, and I'm actually going to write this in a little bit longer form that I prefer. A equals P times 1 plus R over M to the M times T. So our deposited amount, $2,450, times 1 plus 0.0525. See, yep, that's the decimal 2 places over. Divided by our M, which is 4, to the 4 times 6.5. That will give us our compounded amount, okay, which is not what we were asked for. We were asked for the amount of interest. Okay, so we'll have to figure that out. So when we do work this bit out, the compounded amount is $3,438.78. All right, so our interest will take this amount minus $2,450. So that actually leaves us with an interest amount of $988.78. And of course, there's some rounding in there. $988.78. All right, number 4 is just a repeat of this. Okay, so found the amount of interest earned by $1,600, a deposit of $1,600 for 7 years at 4.2% compounded monthly. First, our deposit, $1,600, 7 years is our time, 4.2% is our rate, compounded monthly. That means our M is 12. All right, so A equals 1,600 times 1 plus R, 0.42 over M, which is 12, to the 12 times 7. By the way, if it ever does come down to it, you can actually use the PVM solver for this. A nice little tool that's on TI calculators. All right, so our amount, compounded amount, is 2145. Let's run them together. 2145.75. Again, rounding. Make sure you round to the nearest hundredth place. So that leaves us with an interest amount of $545.75. And since that's what we were asked for, that is our answer. It's the only answer. All right. Example 5. Suppose that $5,000 is invested in a savings account that paid quarterly interest. Okay, so this is the amount it's invested. That's our P. There is a paid quarterly interest, so M equals 4. Quarterly interest. After 6 years, we have all the time, the money had accumulated to $6,539.96. So that's actually a future value, an A, an accumulated amount. What is the annual interest rate? All right, so we're going to go back to this equation. Okay, A equals P times 1 plus R over M to the M times T. But I'm going to plug in what we know. We do not know R. All right, so accumulated amount, 6539.96 equals 5,000, that's our p-value. That's 1 plus r over m is 4, to the 4 times 6. Okay, I may need some extra space for this one. So first thing we need to do is we want to try to get r alone. Okay, that's the big picture. So first thing we can do is divide by 5,000. Divide by 5,000. All right. Oh, I grabbed my calculator. All right. 6539.96 divided by 5,000. Okay, that leaves us with 1.307. And I'm not going to round in my calculator, but I am going to round on paper. Okay, but use the exact value in your calculator. That way you don't lose any of the information. So let's see, 992. Okay, equals 1 plus r over 4 to the 24. All right, now next we need to get rid of this 24 in the exponent, so we will take the 24th root. Oh, draw that a little better. 24th root. All right, so the 24th root of my answer is 1.011. Okay, so 1.011. I'm going to actually round that, stop that right there. Equals 1 plus r over 4. All right, subtracting 1 from both sides, we get 0.11. Okay, so I'm going to subtract 1 in my calculator, so 0.01125002492. Okay, equals r over 4. We will multiply by 4. So we should get roughly 0.44, which is 44%? No, that can't be right. Something's not right here. 0.011. I left off that. Okay. So we multiply by 4, we get 0.04, which is 4.4%. Now let me go ahead and get the exact value. In the calculator, I get, perhaps I should clear that up just a little bit. That is 0.044 with some change. Now, in my calculator, when I subtract 1, multiply by 4, get the exact value, I get 4.045 with several zeros. So R is 4.5%. That is the annual interest rate, and that is what I'm going to stick with right there. Notice, I did convert that. In my calculator, it is 0.045. I converted that to 4.5%. Okay, because that's really what we want. What's the annual interest rate? Okay. Our next problem, example 6. Let me see if I can leave that over here. Example 6. Find the annual interest rate if $6,500 is worth $8665.69 after being invested for 8 years in an account that compounds interest monthly. So first, there is the deposit amount. There's P. It's worth this much. That's the future value. Invested for 8 years. That is our T value. And it corresponds in an account that compounded interest monthly. So M is 12. All right, now I want to show you how you can do this actually with the TVM calculator. If you pull up the TVM, which on the Inspirers it is, you go to Scratchpad menu 8.1 in the finance menu, and then the finance solver is what it's called. In some 84s it is an app, or in 84 Plus it's an app. So, but the way it turns out is you actually have these several blanks to fill in. You have N, you have I, percent. Okay, and it actually wants you to put in there the percent. You have present value, PV, payment, PMT, which is useful in annuities, future value, FV, and then you have PPY, payments per year, and compounding periods per year. All right, so we're going to plug in what we know. In our case, N is M times T, so that's 12 times 8, which in this case is 96. Well, it's always 96, but in this case, N is 96. Okay, so Our interest rate, we do not know. We're going to leave that blank. Present value is $6,500. The payment is 0. We're not going to worry about that. It's called an annuity when you have that. Future value is $8665.69. Payments per year, that's the compound, M, that is 12. And compounding periods per year is 12 as well. These are always actually going to be the same for us. Okay. Now, when you type all these in, okay, and there's actually usually a thing where you select end or beginning. Okay, so you would have, I believe it says payment at. Okay, you'd just leave it as end, that's the default. Again, that's annuities there. So when you type all this in, you go back to this blank, hit enter, and it will populate. And it usually will highlight it in some way too. But when you do that, you get 3.6. Okay, now that is in a percent, so the answer is actually, the rate is 3.6%. Okay, so this will always, and you want to enter this as a percent. That is super important. This is always a percent. Okay, and that's really all there is to that. If we use the TVM solver, be prepared on any exam, any quiz, homework to do this both ways, to solve it algebraically or to use it solve it using technology. All right, one more thing we have to talk about with compound interest, and that is compounding continuously. Suppose that a bank, in order to attract more business, offers to not just compound interest every quarter or every month or every day, but even every hour, but continuously. Okay, going back to the formula, you actually get something that would look something like this. And as n increases, or m is actually what we have there, as m increases, it approaches this equation right here, a equals p times e to the rt. Okay, e being the number, the natural number. Okay, so it's going to be just like our previous formula, so I'm going to kind of skim past this one. All right, so suppose that $2,450 is deposited at 5.25% compounding continuously. Find the compound amount and the interest after 6.5 years. All right, so we are going to take our equation, a equals p times e to the rt. Those are in the exponent. So we want to know we want to know a. So a equals p, which is 2450. I should have underlined that actually. We have our rate, and we have our time right here. So 2450 times e to the 0.0525 times 6.5. And we get a result of 3446.43. Okay, there is our compound amount. Now the interest, we want to find that by taking 3446.43, subtracting 2450, and we should get 996.43. So we want the compound amount, and we want the interest amount. And so there they are. All right, part B of this example, find the time required for the original 2450 to grow to $10,000. Okay, so first I'm going to do this. I'm going to go to my calculator, because I'm actually going to have to find when, let me just go ahead and write the equation out actually. So the accumulated amount, the compound amount is 10,000 equals 2450, our present value, deposit, times e to the 0.0525 to the t, or times t. We want to know what value of t will solve this. Okay, now we haven't done natural logarithms yet, but if you do know natural logarithms, and you can actually solve this using a logarithmic equation. Okay, but what we could do instead is, I'm going to use technology for this. I'm going to find when these two intersect. All right, so I'm going to have two equations. The first one is 2450 times e to the 0.0525 x. Okay, and my second equation, cancel. I think I need to make sure it's using the right e there. go over here. All right, e to the, there we go. Oh, I'm going to have to retype that. 0.0525x. Okay. Next equation, I'm going to hit down, and I'm going to put in 10,000. Now I can't see it, but what I'm going to do is I'm going to pull up my table, which in this case is Control-T. Control-T. And I want to know when this amount right here is going to be 10,000. Now, that's 16,000. Let's see. So it looks like it's going to be somewhere in this vicinity, between 26 and 27. Looks like it's closer to 27. Okay, somewhere in there. The problem is my graph doesn't show me that, but I can actually click and move my graph over. I'm probably going to have to do this instead, though. Take out my table, but it's going to be around 26. I'm going to hit Menu, Window Settings, and I'm going to set this. My X is going to be between 26 and 27. My Y value is going to be between 9,000 and 11,000. So right there is where they intersect. 10,000 and that equation right there. All right, so I can hit Menu, let's see, Analyze Graph, Intersection, and it will let me kind of guess it's somewhere in here. All right, and it's at 26.8. That means the time for it to reach at least 10,000 is 26.8 years. All right, so T equals 26.8 years. And it's really less than that because it's continuously compounded. Okay, we don't actually know the exact amount, but we're going to go with 26.8 years. All right, example 8. Last one on compound interest. Well, for this half-hour lesson anyways. Find the interest earned on $5,000 deposited at 3.8% compounded continuously for 9 years. All right, so there is our principal. There's our rate. Continuously for 9 years. There's our time. All right, so A equals P times E to the RT. So 5,000 times, actually, E to the 0.038 times 9. And so our accumulated amount is 2,000. Oh, no, it isn't. I found the interest already. So 5,000 times e to the 0.038 times 9. Accumulated amount is $7,038.80, rounding that. So therefore, the interest, all we're interested in, all right, is $2,038.80. And there's our interest amount, which is what we were asked for. All right, that concludes the first half of this section. Okay, so it might be a good idea to work on some of your homework assignment before you get kicked into the second part of that. All right.